In 2013, Isaac and Albert's father showed them how to make electricity. In 2017, Albert is at Brooklyn Tech and Isaac can make electricity without the help of his father.
It's Soborno and Bari from Bari Science Lab. Today I'm going to teach you electricity. Electricity is nothing but the movement of electrons. To understand electrons, you have to understand the atom. And remember, atom is the smallest unit of matter. It was discovered by Democritus. You look inside it, you can see three charged particles. I mean two charged particles because neutron doesn't have any charge. The first one is electron and the second one is proton and the last one is neutron. So let's talk about electron first. Of electron is that it's a negatively charged particle. It was discovered by J.J. Thomson in 1897. So the mass is plus 9 times 10 raised to minus 31 kilograms. And the charge is minus 1.6 times 10 raised to minus 19 coulombs. A proton is a positively charged particle. It was discovered by Ernest Rutherford in 1920. And its mass is plus 1.6 times 10 raised to minus 27 kilogram, and its charge is plus 1.6 times 10 raised to minus 31. Talk about neutron. The definition of neutron is that it has no charge. It was discovered by James Chadwick in 1930. Its mass is plus 1.6 times 10 raised to minus 27, and its charge is plus 0. Let's go back to electricity. Remember what I talked about? Electricity is nothing but the movement of electrons. There are two types of electricity. The first one is static electricity, which electron doesn't need wire to move. The second one is current electricity. Now I'm going to show you the example of static electricity. Have a balloon, a wall, and a sweater. They are neutrally charged because they all have the same number of electrons and protons. If I rub this balloon on the sweater will lose the electron. So let's try it. It moved through the sweater because sweater was positive and the balloon was negative. That's everything. I'll show it to you again. So I'm going to hold this balloon over here. And here's the example. If I rub the balloon on the sweatshirt will lose the electrons. So let's try it. Now I'm gonna hold it in the middle again. So see what happens if I let go. It attracts. See? So the electron did not have any wire to transfer from the sweatshirt to the balloon because of static electricity. Electricity. In this case, the electron needs the wire, so I have to build a circuit. So we have one wire. You remember, you gotta break it outside or the other one would suck it up. Now I go close to Fritz. Wow, it's lighting. 9 volts, see?
Wow.
This handsome static experiment, I'm going to use paper, balloons, salt, and pepper. I'm going to blow up the balloon, and then I'm going to rub it on my hair, and then all the acid from my hair is going to move to my balloon, and then I'll use the balloon to separate the paper from the salt and put the salt. Now I'm going to mix it with the knife. Now I'm going to blow up the balloon. To show you the experiment of current electricity. And here's what you need. 2 lemons, make sure they are fresh. Then the strips. 2 copper strings, make sure they don't have oxidation. A knife. A multimeter, 3 alligator clips, the bulb, make it. So first we roll the balls gently so it produces the citric acid, which is the electrolyte. After rolling all of the lemons, you have to make this tiny small battery. We have to create 2 terminals. One is zinc, one is copper. One is anode, one is cathode. Right now I'm trying to put this in. With atomic number is 30. And the atomic mass is 60. Put over here. Now the other one, it's good to see that you have a nice little piece sticking out. So copper is negative, and this, so so you can see it's low, but that's okay. We need to, I rolled this lemon before, so I don't need to roll it anymore. Now I have 2 terminals. One is zinc, one is copper. These are the atoms from the periodic table, and they're neutrally charged right now. Let me tell you all the atoms when we get to this. Hydrogen, number 1, helium, number 2, the lithium, number 3, beryllium, number 4, boron, number 5, carbon, number 6, nitrogen, number 7, oxygen, number 8, fluorine, number 9, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Now I need to make a circuit. That is anode, that is cathode, this is negative, this is positive. I'm going to connect a bulb with this. So I get the bulb, has 2 lights. One is short, one is tall. Yellow is positive, so it's gonna be tall one. Wow! Wow! It's glowing! I'm gonna give you an example of current using the battery and the circuit. So we use a large rectangle and name it as the citric acid, who works as the electrolytes. So we use this as a formula. This. So look how I do this. Now C8O. We start with the O first. 1, 2, 3, 4, 5. I'm gonna write it again. So now the carbon. 1, 2, 3, 4, 5, 6. Now the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. And oxygen. 1, 2, 3, 4, 5, 6, 7. Our neutrally charged atom.
Okay.
Can we have a battery using 2 neutrally charged atoms? Never. So we have to make potential different. So here's the deal, and here's the penny. So now we have to connect it. The alligator clip. So now we remove all the electrons from the zinc, making it the zinc positive. Minus, 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 minus. And the copper negative. Now the copper has 8 minus and 4 plus. Now the zinc has 4 plus. So it's positive zinc and it's negative copper. Now we gotta do the battery. I need the circuit. So this is the resistor, as I say. This is the current or the bulb, which goes this way, and this is the voltage. I have to write Ohm's law, VIR. Now it's V equal to I times R. I equals to V over R, and R equal to V over I. Thank you for watching. Celebrating my birthday on April 9 next month, and I'm going to turn 5. Don't forget to celebrate my birthday. I already received lots of gifts from people around the world, so don't forget to wish me well.